So for this quiz review, I'm going to just kind of go over a couple things, like an example in each category. Okay, so the first thing we want you to graph is an exponential function. And so if you notice in 20, it's a basic exponential function. It's a decay function because the base is between 0 and 1. It's a fraction. 21 is a growth function, but if you notice, it's been shifted. It's going to go 1 unit to the right. And 23 is, again, another growth function because the base is greater than 1, but then it's going to be shifted 1 unit to the left and 3 units up. And so since this is the most challenging one, I'll do that one as the example. So for all of these, what you're going to want to do is graph the basic exponential graph that started it, okay? You're not like the one without the shifts. So in this case, I'm going to first graph y equals 2 to the x power. So I know that my base is going to be 2, and I know that I have two set values here. I've got when x is 0, y is 1, and when x is 1, y is the base, or 2. And so we practiced that enough times to know that those are some pretty standard points. And so I go over to my graph and I graph those. So I go to 0, 1, I go to 1, 2, and then I also know that my original asymptote is always going to be at that y equals 0, right? So this is the graph of 2 to the x power. It hasn't been shifted yet, right? So now what I'm going to do is I'm going to shift it. And remember, let's go back to the problem. I know that it's going to shift left 1 unit, and it's going to shift up 3 units. So every point on that graph that I found, those 2 points, I'm going to go up 3, 1, 2, 3, and left 1, 1, 2, 3, and left 1. And my asymptote is also going to shift up 3 units. It doesn't have to shift left because it's a horizontal line here, but it's going to be at y equals 3. And so my graph is going to go up like that and then come here and hug the asymptote. So my graph is the red one, okay? And I have my asymptotes there. So they wanted us to graph it. We graphed it. They wanted me to identify the horizontal asymptote, so I did right here, okay? It also wanted me to identify the range. And so the range, remember the range is going to be restricted because I have a horizontal asymptote here, and I know that my graph is not going to pass that. And so my range, the y values depicted in my graph are going to be all the y values that are from 3 to positive infinity, like that. And because it doesn't touch 3, it's a parentheses and not a bracket, right? So there's my range, my domain. It didn't ask me for it, but just FYI, it's all real numbers or negative infinity to positive infinity. And then the last question was the y-intercept. And in this case, we got lucky because the y-intercept was easy to identify. It's 0, 5. However, if you want to find the y-intercept from the equation, you go back to the original equation and you're like, okay, y equals 2 to the x plus 1 power plus 3. And if you want to find your y-intercept, you make your x equal to 0. So you come here and you're like 2 to the 0 plus 1 power plus 3. That's 2 to the 1 plus 3, which is 2 plus 3, which is 5. So when x is 0, y is 5. And there's your y-intercept. So those are the questions you're going to have to answer, okay? You're going to have to, now ultimately all I need on the assessment obviously is the red graph, but I do think it's easiest to graph the original and then do the shift. Okay, then we go to the next section and it wants us to use the one-to-one property to solve. And really 25 through 46 are all the same type of thing, except some have a base of e, which is a natural number. So if you were to come here, I'll kind of do a couple of these. I know 3 to the x plus 1. I want to try to make the base on the other side the same. 3 cubed is equal to 27. And once the bases are the same, I can make the exponents equal. So x plus 1 equals 3. So x is 2. When I get to one of these, like 27, I know that 1/2 is 2 to the negative 1 power raised to the x, and this is 2 to the 5th power. And then I can keep going and I can do 2 to the negative x power right? Negative 1 times x equals 2 to the 5th. So I can cancel the 2's. Minus x equals 5, so x equals negative 5. Okay? And so on and so forth. So that's how we do those. When I go to the e's, I'll do a couple of these. Again here, since the base is the same, I can just do 3x plus 2 equals 3. So 3x equals 1, so x is a third. Okay, and the other one, again, the base is the same. 2x minus 1 equals 4, 2x equals 5, and x equals 5 over 2. And you're done. Okay. Again, if I want to evaluate a log, if I want to try to come up with a value, right? Actually, how they want me to do this one is they want me to not use a calculator. They want to say, okay, if I have log base 2 of x, but x happens to be 64, what is the value of this? Well, you can make it equal to y, and you can say 2 to the y equals 64. And I'm like, all right, well, 2 to the y equals 2 to the 6th power, so that means y equals 6, right? Or I can just say, 2 to what power is 64, and I know that it's 6, okay? When I come over to the next one, again, this is going to be log base 25 of 5 equals y. So I'm going to write that as 25 to the y power equals 5, and I know that y is 1/2. Because I know that 1/2 is the square root of 25. And then we keep going over here and we say, okay, log base 8 of 1 equals y. And we talked about this. Whenever log of any base equals 1, we know that y is 0. Now let's just do it the long way to show you. 8 to the y equals 1, and that means that y equals 0, because anything to the 0 power is 1. Now this one here, again, it doesn't have a base, but it's basically log base 10 of 10. And so again, we learn that when you have this, these cancel, leaving you with that exponent. It just equals 1. Okay. Again here, you have log base a of x, and they're telling you that x is a to the negative 2. So these cancel, and your answer is just negative 2. Okay. This one here, again, you have log base b of the square root of b, because that's what we're inserting for x. Now, again, if you remember, the square root of b is b to the 1/2 power. So now that I have base and this are equal, they cancel, and it just equals 1/2. So again, there's some properties there that we learned. Keep practicing those. Now we get over here to logarithmic functions, and again, we have some more. I'll do a few of these because these are kind of quick. Again, log base 5 equals log base 5, and so we know that the two of parts, x plus 1, must equal 6, so x is 5. Again here, this is log base 10, so 11 equals x squared plus 7, minus 7, minus 7. We get x squared equals 4. Now here, I'm going to do the square root, so I'm going to do plus minus. So x is plus minus 2. Okay, so I had to do both. And then here I have same situation. These cancel. And I'm going to get x squared plus 6x equals 27. Now because this was a quadratic, I have to do this one a little longer. It's going to be x squared plus 6x minus 27 equals 0. This is x plus 9. And x minus 3 is 0. So x is negative 9, and x is 3. And there's your answers. Then we keep going, and then again, they want me to sketch a graph of a logarithmic function. And so, again, for all of these, you're going to graph the basic function with this base. You kind of make it equal to y, and you say, okay, 4 to the y power equals x, and you're going to graph that. And then if there's a shift, you'll do that. So let me graph the basic 4 of y, right? We talked about this in class. You're going to just make, let's say, y equal to 0. 4 to the 0 is 1. you'll make y equal to 1. 4 to the 1 is 4. And that's enough points for a logarithmic function. So you're going to come over to your graph, and you'll graph the original. Again, you'll go to 1, 0, and you'll go to 4, 1. For your basic logarithmic function, your asymptote will be the line of x equals 0, and your graph will look something like that. Okay, so that's 4 to the y power equals x. Now we're going to ask you for the domain. Okay, so again, the domain here is my x values, and you're going to see they're restricted because in my graph, x is never going to be 0 or less than 0. So my domain is going to go from 0 to infinity, and my range is going to be all real numbers, or negative infinity to positive infinity. Okay, so that's my range. My x-intercept is important. In this case, since I didn't have any shifts, it was easy. My x-intercept is 1, 0. And my vertical asymptote is here. So this one was really easy. The asymptote is always kind of easy. I think the x-intercept can be a little challenging when there's a shift. I'm not going to give you anything like 45. But let's do one like this one. So when I look at this problem and I see this -3, I know this is going to have a shift 3 units to the right. Okay, so it's going to be the basic 4 to the y power that we talked about. So I'm going to keep that original red one there, and I'm going to graph 44 on that. Basically, I'm going to go 3 units to the right for this graph. So this one I'll do in blue. So each point, I'm going to go 3 to the right. I'm going to go 1, 2, 3 to the right. Okay, I'm going to follow the curve, but my asymptote also has to move 3 units to the right. So let me move that first. And so my line's going to kind of go like that, and it's going to go like that. So the blue one is the graph for number 44. And again, the values now, this is my vertical asymptote, right? My domain for the blue is going to be from 3 to positive infinity. My range is going to be all real numbers. And the last thing they wanted was for me to identify my x-intercept. So again, because I just went 3 units over, the x-intercept was easy. Okay, the x-intercept was 4, 0. Okay, however, that's not always easy. So again, if I had this problem and I needed the x-intercept, another way that you could find it is just to plug in, again, for x-intercept, I need to make my y equal to 0. So I do 0 equals log of 4 to the x minus 3 power, right? So so I would do 4 to the 0 power. I mean, and I could actually have just started. Let me just start this with a y. Like, let me just do it the right way, right? So I would do 4 to the y power equals x minus 3, and then I would make y equal to 0. Okay, so 1 equals x minus 3, and when I add 3 to both sides, I get that x equals 4. So when y is 0, x is 4, and that's my y-intercept. And so you see, it's not terribly difficult to do it. But again, that's everything they wanted in this problem. In the natural log graph, again, it's going to be pretty similar. So we can try one of those. Let's try one like, well, wait, this is just wanting natural properties. This isn't actually wanting me to graph it, it's wanting me to solve it. So again, this is e to the log base e of 4. That cancels, my answer is just 4. This is the natural log of e to the negative 2 power, right? So it's log base e of e to the negative 2. These cancel, my answer is negative 2. This one here would be 2.5 times the natural log of 1. Well, remember, the log, anytime it's of 1, we know that it equals 0. And so this is 0, okay? And that's it for that. And then we come lastly to these change of base formulas. And again, they want to do one with a common log and one with a natural log. So if I have to change the base with a common log, okay, that's a base 10. This is going to be log of 6 over log of 2. And the natural log, okay, that would be ln of 6 over ln of 2. And you'd go to your calculator and you would get those decimals. Each one of these would have a decimal, and then you would divide it and you'd get your answer, okay? And that's the end. That's all you really would have to do there. And then these last ones, expanding and condensing, I'll do a couple of these. Let me do this multiplication one here. So this is going to be log 11 plus log of x cubed. And then this is going to stay log 11, and this is going to be 3 times log of x. And that's expanded. Okay, let's do this one. This is going to be log base 7 of the cube root of x minus log base 7 of 19. This is going to be log base 7 of x to the 1/3 power, right? And this 1/3 would move to the front. So it's 1/3 log base 7 of x minus log base 7 of 19. And there we go. And then, oh, we don't need to do that one. I think that would be pretty much good there. Now let's try condensing. So if I'm condensing, then I have to get it back to 1. So like in 73 here, these are being added, which means really I'm multiplying them, and that's condensed, okay? When I get to 75, let's try that one. That's going to be log of x minus log of y to the 1/2 power, which really I know that is log of the square root of y. And now I'm ready to do the actual subtraction part, which is x over the square root of y. Because remember, when you see subtraction, ultimately, you know a subtraction problem is a division in this type of situation. And then we'll do, I think I'll do this last one, 78, because there's a lot to it. I'm not sure that we're going to give you ones with 2 subtractions. So that one is kind of tricky. I think this one would be an addition if we gave you something like that. Okay. I think that might be more helpful. So if we change that to an addition, right, first we're going to do ln x minus 2 to the 5th power, because I'm going to move this over here, right, plus, and this is going to be ln x plus 2 minus, and this will be ln x cubed, because again, this is going to go there. So now that this is a plus, I'm going to do ln of x minus 2 to the 5th times x plus 2, like that. And then I've got minus natural log of x to the 3rd, and then this minus ends up being division. So x minus 2 to the 5th, x plus 2, all over x cubed. And I think that that would be good enough. I mean, I could simplify this a little bit, this numerator, but I don't think we're going to ask you to do that. Okay, I mean, we can, I think this is really, really good enough. Now, if the problem had remained the subtraction, it would have been a little bit more difficult. I mean, it's not that it's not solvable, but it would have been a little bit more challenging. So I'll kind of draw that one out. If it was the subtraction, right, it would have been minus ln x plus 2 minus ln x cubed. And so I would have had to address this division first, I think. I would have done ln x minus 2 of 5, right, over x plus 2, like that. And then it's minus ln of x to the 3rd. So it's really going to be this over this. So it's going to be ln, right, and or divided. So you think of it like this. You're going to have x minus 2 over 5, x plus 2, and it's going to be all over x cubed, or think of it as divided by x cubed. And so divided by x cubed is really multiplication by 1 over x cubed. So my final answer, I think, would be an x cubed down there. And I think that's what it would look like. But again, that one's a little bit more challenging because, again, you're dividing by 3, which is multiplying by a third, and very, very challenging. But I don't think we would give you that, okay? So this is if both were subtractions. But I don't think that's the case. I think it's a mistake, and I think that we would do addition and subtraction like that. So these are just a little bit of all the exercises that you had to do. I think it's enough of a review, though, to give you a focus on what to study and make sure that you kind of have a general understanding of how to answer these questions.